morning and welcome to lecture 5 of the course titled Introduction to Interaction Design. So, in the last two lectures we discussed how to understand the users, because users are one of the most important aspect when we are designing interactions. So, we just touched upon the area of understanding users and we will be looking at them in the future courses as well, a little bit more in depth. We also studied the process of interaction design, where we saw a few methods like double diamond and other methods which help in identifying the problem and also to come up with better solutions. So, today we will be talking about conceptual design and how and why conceptualizing interactions is important. So, there are broadly two reasons why we need to conceptualize interaction. So, one is that to find out what is the benefit of the proposed product and how feasible is it. So, is it solving some problem of the users? Is it going to add some value, or will it be desirable for a larger number of people? The second reason is that it provides and enables the designers with building blocks with the help of which they can create better interactions. So, for example, for user experience study, the designer will be able to communicate that what would the users require. So, what are those the steps and points that the users will require, and that will help them create a better interactive platform. So, this is also referred to as a proof of concept, where we are checking that how would it fit into the current system and whether it has some value or not. So, let us take an example wherein we need to develop a concept for an application for a city bus service in a metropolitan city. So, some of the questions that would be asked or would come to mind are that why do we need this, what problems would this address, and so on. But if we categorize this particular need in a statement as a problem statement, so we probably would put it together as passengers often face inconvenience due to the lack of reliable system to monitor buses and their routes, which can leave them waiting at stops without any knowledge of their availability, timelines or alternate options to reach these intended destinations. So, you can notice that how from giving a requirement with very wide scope, how we are touching the points which are relevant for the users, and this will help us come up with a better solution. So, once we have put our problem in a problem statement which is neither too generalized and nor too restrictive, then we will come to the next part, which is the research questions. So, research questions give direction to the work, they help us organize our work properly, and also they help us form the objectives later on. So, for the problem that we discussed, the statement that we created, for that problem some of the research questions could be: what are the demographics of the target users in terms of age, occupation, income level? How can the city bus app integrate with other transportation modes like metro, bike sharing or popular navigation apps, and similar other questions. So, you can notice here that how the questions are more relevant as compared to when we were having a very broad statement of creating an app city bus. So, when we begin a design project, we have to be clear about two things. First is assumption. Assumption is basically a problem or need that we are assuming exists. It is not there is no proof that it exists, neither there is any data to back it up, but we are just making an assumption that there is a need for this problem or this particular solution. Similarly, claim on the other hand has a data backed proof which tells whether or not a certain act is happening or certain need is there. So these both are very important to note down or write down, because then we will try to defend or support them, and they can highlight whether the need is vague or whether it really exists. And also, if we have any poorly constructed problem statement or requirement, so we can also work on it and make it more practical. So let's take an example of assumption which says that users prefer mobile shopping apps over desktop websites for making online purchases. So there is no data or proof which is assuming this particular statement, but there is a claim which says that implementing personalized product recommendations increases customer engagement and conversion rates in e-commerce. So probably some tracking has been done which tells us that how, if there are some personal recommendations, customers will they see a larger volume of customers and the business improvement is there. So now here we can form questions, research questions, such that how do users perceive and interact with mobile shopping apps compared to desktop websites, or what are the benefits and drawbacks of personalized product recommendations in e-commerce. So you see that we are able to now explore the assumptions and the claim as well. So the research questions will help us check whether that assumption is true or not, and depending on the problem that we are trying to explore, we can then take this forward. So the research questions will help us create our objectives, and then we can find ways or methodologies how to explore them further. So now questions like, are there problems with an existing product or user experience? If so, what are they? So when the team is interacting with the users and these kinds of claims and assumptions are discussed, so the perspective that we receive, it helps us take the work forward. Or why do you think there are problems? So the user will respond to these, and we will come to know whether it is a good idea or not, and whether it should be implemented or taken forward or not. Now coming to conceptual models. So some software developers, when they started developing applications, so the first step was implementation of the functionality. So they defined the application's architecture, wherein the platform, functional modules and communication protocols, they are all prepared, and then they begin implementing the modules, protocols and onto the platform, and only once the functionality part is complete, then they see that how will the user use this particular application. So this was predominantly the style in which software developers used to work a few decades ago, and the functionality was first and they applied the interaction later on, and they thought that the user will adapt to it. But these software applications were even very difficult for these engineers and scientists to work on, because they are very complex, they were not user friendly, and they were not efficient, and there was a lot of time and energy went in understanding that how it even works. But later on in 1980s and later on, when software application platform opened for more people, not just limited to the scientists and engineers, so now more exploration started happening, because the user came into the focus and user became the important person who would be exploring. So the system was modified, and few of these developers, software developers, they know that functionality first and then UI approach, user interface approach doesn't really work well, and so they rejected that approach and they started to begin designing applications by focusing on how people will use it first and then working on the other technical aspects. So, conceptual models and conceptual design, these two should not be confused, because sometimes people associate them with concept design or design concept. So, design concept and concept design, these terms are for early brainstorming phase, where quick prototypes are prepared, where quick ideas are generated on the storyboard, and this process inspires innovation, and generally out of the box solutions are applied here. But this is not what we mean by conceptual design or conceptual model. So, we will probably get a little bit more clarity. So, here we can see that how the conceptual design fits into the user task center design process. Now, we can see it is a cyclical process. We can see how it is going around in a circle, and maybe starting here from understanding the user needs, going to conceptual design, UI design, and then the initial evaluation. So, you can see how the UI has been integrated early on in the newer model, and then review, implementation, and evaluation. So, all of these steps hold a lot of importance when it comes to the conceptual design, because implementation will ensure that the platform is user friendly and it is robust and reliable. The UI design will ensure that user is having a positive experience. The release is also important, because the time of release of this application, how time bound is it, so all those points will be important. And once we release, an application is in use, then support becomes important, because support is directly involved with the users and user needs. So, again the support will inform that what are some of the gaps still remaining in understanding the user needs, and then they are incorporated, and again this cycle starts. So, you can also see some arrows are here, some are double head arrows, some are single headed arrows, and they are informing that how the conceptual model is integrating the information at a later stage as well. It is not as if the conceptual model, once it is ready, it is set in stone. It can still be changed even after the release of the application, because there might be some lacuna, there might be some other things that were overlooked, and then this, depending on what was overlooked, so the arrows indicate that how it is a fluid process, it is not a linear process. So, some of the important requirements of the conceptual model is that it needs to be simple. So, it should be as simple as possible, and less is more is basically the important keyword here. Now, let us take an example that for example, we have to create a to-do list. That application needs to be designed. So, after doing the user study, we come to know that users would like to prioritize their needs in a hierarchy of two, most important and less important, for example. But now if the designer adds more such hierarchies into it, so that will make the application more complex than what the user was earlier expecting. The broad majority wanted only two hierarchies, but now there are more than that. So they will create some confusion. The other one is the task focused requirement, that models should map as directly to the target task domain as possible. So, for example, we have a book and we need to Xerox one page on 2 pages, same page on 2 pages of A4 sheet. So what would be the steps in achieving that? So we will first put it on the machine, take out prints. If we need 50 prints, we will take all odd side. Then we will probably remove the whole bundle, turn it around, and then print on the even side. So there are machines which are more automated, which can probably do this task automatically. But the previous example that we saw, that provides the gulf of execution for the user, which is that a task that a user wanted to accomplish, now he is not able to accomplish because there are so many challenges. What if the page is not in the right direction? What if the print comes upside down? So there are many hurdles or thought processes that will be involved and will deter him from reaching his final goal as quickly as possible. So the conceptual model that we design, so it has to be tested with the users or other task domain experts. So before we work further on it, so such testing may inform us the conceptual holes. So these conceptual holes are certain problems that may be there, certain gaps, but they can be filled up, and the revised model can be then returned for assessing the user needs again. Now, sometimes what happens is that once the conceptual model is used for creating the user interface, the designers abandon the conceptual model. But that is not a very good practice. The reason being that even after the, for example, an application has been released, user testing results later also can be incorporated in the UI. But once all of that has happened, the feedback has been taken, but the application will lack a very solid conceptual ground. So that will be missing because we have not updated our conceptual model. So it is, although a difficult task to rework on the conceptual model because it takes time, the team may get exhausted, but it is important that the conceptual model is refined as per the feedback that we are receiving. And what is important to remember is that the conceptual model is the primary of primary importance. So it should not be neglected, and one should not just rush to create the architecture of the application, for example. So in the last lecture, in the third lecture, we had seen some of the processes of design, where we also saw the agile process, and this is just breaking down the whole system so that we can see it in 3 phases, wherein the inception phase, we can see that once the problem starts, the user profiles are created, and again it is like a cyclical manner where we are working on it. The dotted lines, they show how the information is going back in the loop, and then once that we have achieved the optimum level, we go on to the task analysis, where we identify the essential use cases, and again you can see the dotted arrow is taking it back, and then we move on to the conceptual model. So once this knowledge base we have, which is of the user and the task, so now we can create our conceptual model, wherein we employ paper prototypes, so we can still explore many options to create our conceptual model. Once we are satisfied, then we move on to the high level storyboard, user interface, or the high fidelity prototypes. We will talk about these also in upcoming lectures. And of course, then the style guide is created, and then the detailed user interface design is worked upon, which again we can see cycle 1 to cycle n, which means that there may be, it's expected that there will be more than one of these cycles. So this is a good example to see how we can arrange our project, how can we break it up into these simpler phases and then find solutions. So, a very good example of conceptual model is the star interface, which was developed in 1981 by Xerox, and this has helped change the way the interfaces were designed, and now it is also in use. You can see glimpses of this in Mac and even in Windows. So it was originally designed as an office system for workers who were not interested in computing, and it was based on the conceptual model that included the familiar knowledge of an office. So here the conceptual model that they took was, since our employees are not interested in computing, but still we have to communicate information to them, because some paper needs to be moved, some mail has to move around the office. So taking actual products like a file or a dustbin or a mail, symbol of a mail, the email, post mail. So using those as identifiable icons, now the users knew that if this is a file folder, so the file has to be moved into a file folder. Of course, it is not moving physically, but still on the screen that movement shows that it has moved from one location to the other. So this is one example of how we create these conceptual models, and depending on the situation and the problem, we can derive inspiration from many sources, and we will be looking at this in the future lectures as well. So this is all for today's lecture. Thank you and see you.